Hi there, and welcome to today's class. For this class, we're diving into chemistry, discussing about the concept of percentage composition by mass of an element in a compound. So, how do you possibly calculate the percentage of composition by element in a compound by mass of an element in a compound? So, when it comes to calculating the percentage composition by mass of an element in a compound, there is a mathematical expression, or let me call it a formula for calculating the percentage composition by mass of an element in a compound. So, when it comes to calculating the percentage composition by mass of an element in a compound, here is the formula here. The formula is given as percentage composition is equal to the mass of the given element or mass of element all over relative molecular mass of the compound times 100%. So this becomes the mathematical expression for calculating the percentage composition by mass of an element in a compound. So suppose they are taught to calculate the percentage composition of a particular element. Simply take the mass of the element divided by the relative molecular mass of the compound times 100%. let's now use this mathematical formula or this expression to solve some problem. So let's say we are told to find the percentage composition of an element, or let's say we are told to calculate the percentage composition of by mass of an element in this compound here. Let's start number one there. Let's start number one. I have CH2O. When it comes to percentage composition by mass of an element in a compound, the idea is that you'll be told to find given a compound, and you'll be told to find the percentage composition of one element among them. For this one, you might be told to find the percentage composition of carbon, if you want to, just one element, or perhaps oxygen or hydrogen. But for teaching sake, I'll calculate for each of them. So note that when it comes to exam, you'll be asked to calculate the percentage composition for either carbon or oxygen or hydrogen, either one of them. But for explanation's sake, I'll do for each of them. So let's start for carbon. For this carbon here, listen. What we know is that percentage composition is equal to what? Percentage composition is equal to what? Mass of element all over what? The relative molecular mass of the compound per se, of this compound, next up, times 100%. So what's the idea? For me to calculate the percentage composition of each of them, I need to know two things. Number one, mass of the element that I'm looking for, and the relative molecular mass of the compound. So my first task now, I need to get the relative molecular mass of the compound. So calculating for the relative molecular mass of CH2O. That's my first task. I have done a video on how to calculate the relative molecular mass of a compound. So you can click on the link you see up here, right? It will take you to our class on how to calculate relative molecular mass of a compound. Or if you want to, you can check the description of this video. So you see a link there, right? So at this point here, let's get the relative molecular mass for CH2O. We know that C is 12 plus hydrogen is 1 times these 2, yeah, plus oxygen is 16, as we know before now, and they are here too. So from here, 12 plus 2 plus 16, that will give about 30 gram per mole. So the relative molecular mass of this compound here is what? 30 gram per mole. So I've gotten this one here. Now let's start. We said when it comes to this man here, you'll be told to find just one element in the compound. They just say find the percentage composition of carbon, that's all. Or perhaps find the percentage composition of oxygen. They'll ask you to look for one. But for teaching's sake, I want to look for everything. Let's start for carbon. For carbon, see, what do we know? The percentage composition of carbon is equal to said mass of the element. What's the mass of carbon here? The mass of carbon is of course 12. I'll have 12 all over relative molecular mass of the compound, which is what? 30. All over 30 times what? 100%. 100. So it means that the percentage composition of carbon is equal to 12 divided by 30, 12 divided by 30 times 100. So I have, 12 divided by 30 times 100. I have 40%. 40%. So my when I calculate the percentage composition of carbon, I have 40%. Let's get for hydrogen. So this for carbon. For hydrogen, H, we said the percentage composition is equal to what? The mass of the element. What's the mass of hydrogen? That's about 1. That's 1. But observe that hydrogen is 2. Yeah, this is 2 atoms of hydrogen. That is times 2. Don't forget, please. All over, we said relative molecular mass of the compound, which is what? 30. 30, yeah, times 100%. From here now, the percentage composition, what is it there, of hydrogen becomes 2 divided by 30 times 100. I have about 6.66 percent as my percentage composition of hydrogen. Let's get for oxygen. For oxygen, O, we said the percentage composition is equal to what? Mass of the element. Which element are we considering now? That's oxygen. What's mass of oxygen? Oxygen is what? Is 16, right? Okay, it's not here. Oxygen O is 16. So I have 16 here. All over 30, which is constant here, times 100%. At this point, getting value, the percentage composition of of oxygen is equal to 16 divided by 30. 16 divided by 30 times 100. I have 53.3%. So when it comes to exam or WAEC or JAM, the idea is that you'll be asked to calculate either for this one now, for this compound now, you'll be told to calculate either for carbon, which is 40, or for hydrogen, which is what? Which is 66.66, or for what's it called? Or for oxygen, which is what? 53.3%. So you'll be asked to calculate one, but for teaching sake now, I did everything. I calculate for each of them. Now, don't now make a confusion that you say calculate the percentage composition, or perhaps they will ask you that, you know, we have done for carbon, hydrogen, and oxygen. They now ask you that which element here has the highest percentage composition. Looking at this one now, because hydrogen is having two, some people will now say that hydrogen has a higher what percentage composition. That's wrong. Observe, carbon is what 40%, hydrogen is what 6.66%, while oxygen is what 53.3%. Which one has the highest percentage composition? That's oxygen, 53. That's oxygen, right? So now what I want you to note now is that if I sum up each value, I will have 100 back. So if I sum up the percentage composition of carbon, that's 40 plus 6.66 plus 53.3, I'll have 99.96, which is approximately what the 100%. So it means if I sum up the value for each element, if I sum up the value of the percentage composition of each element, I'll get back what 100%. So they might ask you now, look up. They might ask you that given the percentage composition of carbon as 40 and hydrogen has 6.66, what is the percentage composition of oxygen? The idea is what? Add 40 plus 6.66, add them together, take away from minus from 100%, so you be left with what 53.3. So the idea is that if I sum up the value of the percentage composition of each element, I'll get what 100%. Add this one, this and this, you get 99.96, approximately 100%. That's the concept behind what's it called, percentage composition by mass of an element in a compound. Let's say we're told to calculate the percentage composition of chromium in this compound. So let's get this done. Let's do number 2. Let's do number 2. For number 2 there, I'm told to calculate the percentage composition of chromium. That's Cr. So I'm having number 2 there. I have K2 Cr2O oxygen there. So I'm told to calculate the percentage composition of chromium, just chromium alone. Don't go ahead and say potassium, then you start no, just only chromium alone. So to calculate the percentage composition of chromium, I need what? The mass of element, which is mass of chromium, so I need the mass of chromium, right, all over what? The relative molecular mass of the compound, right, times 100%. So let's get the mass of chromium. That's quite simple. The mass is 52, yeah? So what I need majorly now is what? The relative molecular mass of the compound, this one here. So let's calculating for the relative molecular mass of C2Cr2O. You can actually watch our previous class on how to calculate relative molecular mass, which I'll drop the link in the video here, in the description of this video. So watch it to understand how to calculate for relative molecular mass of a compound. All right, having potassium here. What's the mass of potassium? That's 39. 39 times 2, this 2 here, 2 atoms of potassium, plus this is chromate. This is 2 atoms of chromium. That's 2 times chromium is what? 52. 52 plus this oxygen, that's 16. From here, 78. 39 times 2 39 times 2 is 78 plus 104 plus 16. 2 times 52 will give 104. Add them up, plus 104 plus 16. I have 198 gram per mole. So it means that the relative molecular mass of this compound here is 198 gram per mole. So now the idea now is that let's guess what the percentage composition of what of chromium. So it means that the percentage composition of chromium, so for chromium, what we know now is that I need what? So therefore, all right, the percentage composition of chromium is equal to mass of chromium. What's the mass? What's the mass of chromium? 52. I have 52 times 2. Why times 2? It is 2 atoms of chromium. That's times 2. All over the relative molecular mass of the compound. That's what? 198 times 100%. So it means that the percentage composition of chromium is equal to what there? I have 52 times 2 divided by 198. So times 100%. So the percentage composition of chromium is 52.5% as my answer after finding the percentage composition of chromium in this compound. So this is how to find the percentage composition of an element in a compound. So see you in our next class.